Alright, so completing the square, one of our key steps is to make sure that our leading coefficient is 1. So here we have a case where we got to do a little work before we can complete the square. Right? I have a 2 in front, so I got to take everything and divide by 2 first. Okay, so 2x squared divided by 2 will give me x squared minus 2x minus 5 halves. Leave it as a fraction, please and thank you. Okay, so then now we're going to follow the same process. Right? We're going to move our constant over. X squared minus 2x, leave a little bit of space, equals 5 halves. And then to figure out what we're going to use to complete our square, we're going to take our middle term b, take half of it, square it, and then add it to both sides. Right? So negative 1 squared gives us 1. We're going to add 1 to both sides. So our left side will factor into x and then whatever it was that we were squaring, x minus 1, oops, x minus 1, quantity squared. That is equal to 5 halves plus 2 over 2 would give us 7 halves. Okay. And then let's take the square root of both sides. Because we are the ones introducing the square root, we gotta put a plus or minus. And that radical is over the 7 and the 2. Okay. Meaning that x equals 1 plus or minus the square root of 7 halves. It is improper mathematical practice to leave a radical in a denominator, because right now this is technically root 7 over root 2. So what we need to do is rationalize this denominator. Let's multiply by the square root of 2 over itself, which will leave us with the square root of 14 over 2. Meaning that x is equal to 1 plus or minus the square root of 14 over 2. And that is what we want. So same process, but we just had to divide by our leading coefficient 2 first. Like I said, completing the square works every time. Okay, so solving quadratics by factoring only works when we have real integer solutions, but completing the square will work no matter what. So sometimes we may encounter complex solutions or imaginary solutions, and we can just proceed as normal. Okay, because we have radicals, we have the potential to have a square root of a negative, but it's going to be all fine. Okay, let's subtract the constant from both sides first. X squared plus 2x, I'm going to leave a little bit of space. It's equal to negative 7. And then to figure out what we're going to add to both sides to complete our square, we want to take the middle term, middle coefficient 2, half of it, and then square it. So 1 squared is 1. We're going to add 1 to both sides. Meaning that we'll have, let's see, this will factor into x plus 1, quantity squared equals negative 6. Take the square root of both sides, x plus 1 equals, because we are the ones introducing the radical into the problem, we have to put a plus or minus. So x plus 1 equals plus or minus square root of a negative 6. And so this is square root of a negative number, we got to put an imaginary in there. All right, so let's say x equals negative 1 plus or minus I times the square root of 6. And that's what we want. So this type of parabola is one that would either open up or open down. But because this leading coefficient is positive, it's going to open up, right? It's going to open up, meaning it sits above the x-axis and it's never going to touch it. That's what it means when we have two imaginary roots. Okay, so this plus or minus gives us 2 roots, right? Because we technically have negative 1 plus I root 6 and negative 1 minus I root 6. Those are our 2 roots, right? 1, 2. And so that's that. We can just represent them as 1. There are 2 separate roots, but with that plus or minus symbol, it represents 2 of them. Okay. Pause the video, give this one a try. Remember that you have to divide by 5 first. For real, pause the video, give this a try. It will not bite. Okay, so first thing we're going to do is divide everything by 5. So x squared minus 3x plus 12 over 5 equals 0. And then let's move our constant over. X squared minus 3x, I'm going to leave a little bit of space, equals negative 12 over 5. And then let's see what we're going to add to both sides. So take your middle coefficient, -3, take half of it and square it, which will give us 9/4. Okay, 9/4. That's what we're going to add to both sides. So this is a situation, since we're working with fractions, it's super helpful to write out this part, right? Because then now we know, oh, when I factor it, it just turns into x minus 3/2 squared. Okay, equals, let's do some very careful integer addition, not integer, excuse me, rational number addition. If we multiply this time, 12/5 to get a common denominator, we want 20, so maybe -48/20 plus 45/20. You can do this with a calculator, but it's good for your brain every once in a while to, be used. So if we add these together, we should get -3/20. Leave it as a fraction, please and thank you. Fractions are our friends. Now we're going to take the square root. Because we are the ones introducing the radical into the problem, we have to put a plus or minus. So x minus 3/2 equals plus or minus square root of -3/20. That radical extends over both the numerator and the denominator. We had a negative under there, so we're going to have an I at some point. X equals, add 3/2 to both sides, x equals 3/2 plus or minus I square root of 3/20. Remember, it is improper mathematical form to leave a square root in the denominator. So we need to work a little bit with this √3/20. A couple options here. You could just multiply everything by √20/√20 and then simplify from there. Or you could simplify the square root of 20 first and then see if there's anything that will come out of the radical and then just multiply over whatever is left under the radical. So to show you what I mean by that, this is what I mean. All right, so let's take 20. 20 breaks into 4 and 5, meaning that the square root of 20 will become 2√5, right? So I really am working with square root of 3 over 2√5. So then to simplify this, it'll be kind of like a more direct route if I just multiply by √5 over √5. Okay. I'll end up with √15 over 2 times √5 times √5. These √5s are going to come together to form 5. 5 times 2 will give us 10. Right? That was too fast for you. Sorry. It just is, right? So you could simplify and then solve, or solve and then simplify. I'll do it again if needed. So we took √3 over √20. We simplified 20 into the square root of 4 times 5. And then we brought our 4 out in front of the radical to get 2 times the square root of 5, meaning we're really working with this, right? Square root of 3 over 2 times the square root of 5. We multiplied that over √5 over √5 to get that radical out of the denominator. And then the square root of 15 comes from the 3 times 5 being multiplied together. And this 10 comes from 2 times 5, right? √5 times √5 will give us that. So that's what we're working with. Let's see, where does that fall in here? X equals 3/2 plus or minus I √15 over 10. All right, should check out. If you're getting something a little bit different with simplifying that fraction, it's possible that I made a mistake somewhere in here, but I tried to write out my steps to avoid that. All right, that is completing the square. It's not really anybody's favorite. People tend to forget that it's an option when solving quadratics because people like factoring so much. Next section, we'll look at another method that works anytime. All right, take a look at the practice. Let me know what questions you have.